We all make calculations every day, sometimes to know how much we are worth. Do you ever wonder why we only use the numbers 0 to 9? Yeah, you heard that right. 25,169, for example, only consists of digits between 0 and 9. I mean, think of this. The name Anderson is not an English alphabet, but it's a combination of letters from A to Z. A number system that only allows the use of numbers between 0 and 9 is called decimal. Other number systems such as hexadecimal exist, a system that uses 16 different characters. 0 to 9 makes up the first 10, and to make up the other 6, we cannot use number 10 because it's not a single character. So, the alphabets A to F are used to represent 10 to 15 in hexadecimal respectively. A common use of this number system can be seen in MAC address representations. Computers, on the other hand, do much more work, and they use the simplest system of all, binary. Only 0 and 1 are used. Everything on the computer, text, image, video, software, is only known to the computer as strings of 1s and 0s at low level. If a guy owes me this much money in binary, how much does he actually owe me? Let's find out as we talk about binary to decimal conversions. Hello guys, today we'll talk about binary numbers and some facts which makes them an easy tool to work with. How did we know that the number on your screen is 5,276? This is divided into 4 groups. 5,000 is more significant than 200, which is more significant than 70, and 70 is more significant than 6. The least significant digit is 6, hence we assign an index of 0 to it. We go further with 1, 2, and 3 in increasing order. Now, we find the weight of each number based on their position. The least significant number in any number system always takes a place value or weight of 1 since it has a 0 index. Decimal consists of 10 characters, so we multiply by 10 to get the weight of the next value. Repeat this process as the index increases to generate the rest. It would interest you to know that generating these place values can be done by simply evaluating 10 to the power of the corresponding index. This is called 1,000, 100, 10, and this a unit. To read this number, we call it 5,200, 7 tenths, which is 70, and 6, 5,276. Binary isn't so complicated. You deal with only 1 and 0, also called bits. Looking at our dollar, if this is actually in binary form, then we call it 11000. The least significant bit has an index of 0, and the index increases, just like the decimal, until you reach the most significant bit. Like the decimal, the least significant bit has a weight of 1, and we generate the rest by multiplying with 2 each time, since it's binary. We sum up weights of 1s only, since zeros do not add anything. You're only getting $24, not 11,000 like it looks. So, if someone says they owe you $100, be sure they're not speaking binary. Conversion from binary to decimal and vice versa is easy. Just find all the weights that add up to the decimal number and set corresponding bits as 1s. And all weights that are not used will be assigned 0 bit. Hence, to obtain the binary form of the decimal number 160, we set the bits under 128 and 32 only. Here are some key points about binary. If this bit has a weight of 128, the sum of all weights before it is 127. If this is 32, the sum of bits before it will be 31. Hence, this is 16 in binary and this is 15. To obtain 13, we turn off this bit having a weight of 2. Combinations. How many decimal numbers can we get if only 2-bit positions are available? 1, 2, 3, and 4. We have 4 possible combinations representing the decimals 0 to 3. This is one way to do this. An easier way is to only fill the spaces with zeros and then fill the spaces with ones. This still gives decimal numbers 0 to 3. The easiest way to do this, however, is to evaluate 2 to the power of n, where n is the number of spaces provided. 2 raised to the power of 2 is 4. So for 10 binary positions, we can have 2 to the power of 10 possible combinations. This concept will be used a lot in subsequent presentations. Check out the questions on the next slide. If you like this video, you can give it a thumbs up and subscribe to our YouTube channel. Please turn on notifications so you'll be the first to know when we release a new video. Thank you for watching.